Big trucks sound different when they stop. There's a sharp hiss of air, followed by a heavy, controlled slowdown. It feels deliberate, almost mechanical, and very different from the quiet braking of a car. That sound raises a common question. Why do big trucks use air brakes instead of the hydraulic brakes used in normal cars? The answer has nothing to do with being old-fashioned or over-engineered. It comes down to physics, safety, reliability, and what happens when things go wrong. To understand this, we first need to look at how car brakes work. Most cars use hydraulic braking systems. When you press the brake pedal, fluid is pushed through sealed lines to brake calipers at each wheel. That pressure squeezes brake pads against a disc, creating friction that slows the vehicle. Hydraulic systems work extremely well for cars. They are compact, responsive, and efficient for lighter vehicles that stop frequently. But they rely on one critical assumption. The system must remain sealed. If hydraulic fluid leaks or pressure is lost, braking power drops sharply. In a car, that is a serious problem. In a 40-ton truck, it is catastrophic. This is where air brakes come in. Air brakes are designed around a different philosophy. Instead of relying on liquid pressure to apply the brakes, they use compressed air stored in tanks. When a truck is moving, its engine powers an air compressor that fills these tanks. Pressurized air is then used to control the braking system. The key difference is what happens when something fails. In a hydraulic system, failure reduces braking force. In an air brake system, failure applies the brakes. This is called a fail-safe design. If air pressure drops below a safe level due to a leak or mechanical issue, powerful springs automatically force the brakes on. The vehicle slows down or stops instead of losing control. This single design feature is one of the main reasons air brakes are required on heavy trucks. Weight is another major factor. Big trucks carry enormous loads. Stopping that mass requires far more force than stopping a passenger vehicle. Air systems can generate and sustain much higher braking forces without overheating or fading. Hydraulic systems can struggle under continuous heavy loads, especially on long downhill stretches. Air brakes are better suited for that kind of stress. They also handle heat differently. When brakes are applied repeatedly, they generate heat. Excessive heat can reduce braking effectiveness, a problem known as brake fade. Air brake systems are designed to manage this better through larger components and controlled application. They are built for endurance rather than quick stops. Another reason air brakes are used is redundancy. Truck braking systems are divided into multiple independent circuits. If one part fails, others continue to function. This layered approach adds safety in real-world conditions. Cars do not need this level of redundancy because their mass and operating conditions are far less extreme. There is also the issue of trailers. Big trucks often pull trailers, sometimes multiple ones. Air brake systems allow braking signals to be transmitted easily between the tractor and the trailer. Compressed air travels through flexible lines, applying brakes across the entire vehicle combination simultaneously. This coordination is essential for stability. Hydraulic systems are far more difficult to extend safely across long, articulated vehicles. Maintenance is another consideration. While air brake systems are complex, they are also robust. They tolerate minor leaks and wear better than hydraulic systems. Small issues can often be detected through pressure readings before they become dangerous. That hissing sound people notice is often air being released intentionally, not a malfunction. Drivers are trained to monitor air pressure constantly. The system provides clear warnings if pressure drops too low. This transparency is a safety advantage. There is also a regulatory component. Due to the size and potential danger of heavy trucks, safety standards are much stricter. Over time, air brakes proved to be the most reliable way to meet those standards consistently. Once that became clear, air brakes became mandatory for large commercial vehicles in many regions. This created a standardized system across the trucking industry, making training, maintenance, and enforcement more effective. Some people assume air brakes are outdated, but that is not accurate. Modern air brake systems are highly engineered, incorporating electronic controls, sensors, and advanced diagnostics. The basic principle remains the same, but the execution has evolved. Air brakes persist because they solve a problem better than alternatives. There is also an important psychological aspect. Truck drivers rely on predictable behavior. Air brakes provide consistent feedback and response, even under extreme conditions. That predictability builds trust. In high-risk situations, trust in equipment matters as much as technical performance. Understanding this makes the system easier to appreciate. Air brakes are not used because trucks are different for the sake of being different. They are used because the consequences of failure are far greater. Design choices follow risk. For small vehicles, hydraulic brakes are sufficient. For vehicles weighing tens of thousands of kilograms, a different approach is required. Air brakes represent that approach. They prioritize safety over convenience, redundancy over simplicity, and controlled stopping over quick response. That is why big trucks use air brakes instead of normal brakes. Not because they are louder, older, or more complicated, but because they are safer for the job they are meant to do.